Hello? Hello? Hello everybody, I'm back, and we're gonna make another video here discussing this concept that I just, keep thinking about randomly throughout just my life. And it's this 0.999 to infinity. So with this, there's two ways to get 0.999 to infinity. And this way is 1 divided by 3 equals 0.333 to infinity, and then you multiply it by 3 and you get that. So you see there was a conversion and then a multiplication to the product of this conversion, but this is wrong because 0.333 to infinity has not finished. It's incomplete and it needs to finish in order for it to go into the next order of operation, which would be to multiply it by 3 to get 0.999 to infinity. Now there's another way, which would be a correct way, but I would say very improbable finding it really in our world. So it would be 1 minus 1 over 10 to the power of infinity. I know you can simplify this. I'm just thinking about it. I think it was this one. 1 minus 1 to the power of negative infinity. Yeah, I've been thinking about these. So yeah, fact, 0.333 to infinity is an incomplete division that has not been solved yet. Thus, doing any operation on this infinitely repeating decimal is always wrong because you would be skipping the order of operations. First, solve 1 divided by 3 or 1 minus 1 divided by 1 times 10 to the power of infinity, right? So with that, it just it comes to a screeching halt, So does 0.999 to infinity equal 1? The answer is no. We just proved it, right? I mean, this is one way of getting it, and any other variation of this logic is just, it's just simplifications or complications. It's always this minus. For minus, you could probably get something with multiplication, division, or other things to get 0.999, but I doubt it. I mean, to get it from division, it would be 99999 to infinity divided by what, or is it the other way around or something? I don't know. I mean, it doesn't work. It just doesn't work. So let me see. So I was here doing this 0.3 times actually this would be from my other video, which would be placing fractions in decimal places, and I mean it works out, just works out. So I did see something very interesting in Desmos. So 1 minus 1 divided by 1 times 10 to the power of 1, you get 0.9. Okay, so now you see the logic of the equation. If I plug in 2, it's 0.99, and that would be plugging it in right here. So if I change it to 12, that 1, I'll get 0.99999 to like what, couple decimal places, right, of repeating 9s. But as soon as I put 13, this whole thing equals 1. And you know what that means? It means that Desmos is telling me that negative 1 divided by 1 times 10 to the power of 13 equals 0. Like, what the fuck? Today I proved that, right? Because, I mean, if you go to Desmos, you could see it right here. Let me just go. So it'd be right here. Right. So 13, right? What happens if I put 26, right? I mean, Why isn't it like like -1? So like, why isn't this 2, right? Why doesn't 26 give me 2 instead of 1? Because 13 gives me 1. 26. What about 36? So yeah, it's just bullshit. Because, you know, I broke the matrix or what? I'm just kidding, but yeah, you know how it is. You know, it just comes down to, you know, me being right and the internet being wrong because I'm smarter than the internet. The answer is no, right? Or, I mean, how else would you get it when you know that this is just wrong? This isn't a complete product of a division. It's not a complete number. It's nothing. It's still being completed. You have to wait until it's finished. And this, which has already been completed, which stands for 3, is multiplying and waiting for this to finish, but it never finishes. But this, I mean, if you undo it, you would get 1 divided by 3 times 3, and that equals 1. But this is not the same thing as 1 divided by 3, because remember, this is an incomplete division product, and 1 divided by 3 is just a fraction. So this is a whole concept that's on a different, you know, like, we're just talking about something different. It's still not finished. So if you want this to be 3, you're gonna have to convert it into 0.3, and then you place a fraction, and what's that fraction? Would be 1 divided by 3, right? But that doesn't make sense. So, I mean, it does make sense if you see the equation that I came up with to figuring out how to even get this, because you would have to divide this by 3, right? Because it's 3 divided by 3 minus 1 to the power of negative infinity divided by 3, and if you look at it from that, it's 1 divided by 3, and then just that. So it would flip it on its head. It would be I don't know, but yeah, it makes sense. I mean, it's just 1 divided by 3, right? So it would be 0.3, and then you place a fraction, 1 divided by 3, because I mean, it's the same thing right here, just 1 minus, to get this, divided by 3, and but you see there's a subtraction there. And this is just saying like a multiplication of 3, but it's just a subtraction of a repeating number 3 times. So yeah, it is like division. So as you can see, this is not nothing. This is nothing. These are not finished. These are nothing. It has to be either that for that, or it has to be this for that. You can't use this. You can use that. Why? Because this has not finished. Either undo it and take your 1 over 3, or let this finish. And guess what? This never finishes, so you can never use it. That's order of operations. Come on, bro. And then, yeah, I mean, it speaks for itself.